Assembly of inserting section. After rhodite is cured, apply molybdenum disulfide on the portion of DAU to be inserted into bending section. Assemble bending section onto DAU. Bending section should be assembled in such a way as up undulation is directed to up position. Apply flux on the area to be soldered. Solder 2 or 3 spots. Be careful not to solder adjacent to FCT. Excessive flux should be cleaned by paper or lint-free cloth, dampened with appropriate solvent, such as ethanol. Contents such as tubes, LG, and CHA cable should be so arranged as to be in the same order as that of distal end and tied with enamel wire. Tying interval may be 10 to 20 centimeters. 4 undulation wires should be put together gradually toward the antrum end of inserting section. Apply heat shrinkable tube on CHA cable. Heat the tube for shrinking. Apply enough molybdenum disulfide dissolved in alcohol on contents which are to be inserted into flexible section and dry it for some 2 hours. Put undulation wires together at the end with Scotch tape. Same as with end of CHA cable. As removing enamel wire, insert into flexible section gradually. Make sure that up position of bending section and flexible section is properly located and put them together. Apply some flux and solder. File excessive solder. After smoothing, apply molybdenum disulfide on the net of bending section. Insert angle rubber RBS into the jig and fold both ends back. Connect the jig to a vacuum pump and inflate RBS. Parting line of RBS should be so located as in lateral position of flexible section. After aligning parting line, detach RBS. Let's show how to coil thread using a model. To finish coiling, draw a loop into the coil. Coil thread as tightly as possible without any gap. Lengths of thread coil may be 1.5 mm to 2 mm. After coiling, apply Aron alpha, slightly to prevent loosening. Cut both ends of thread. Take care not to perforate RBS with the knife edge. Cut both ends of RBS. Air tightness test of ISA. Check for any leakage of ISA. Plug every tube with jig and put ISA in the air tightness tester. Apply pressure of 0.3 kg per square centimeters. Gauge gradually. Soak ISA in the water and keep for about 2 minutes. Check for any bubble. Assembly of ISA. Insert contents of ISA into operating section in specified order. Connect ISA to operating section, taking care of undulation wires. Fasten 4 screws to fix ISA and operating section. Assembly of LG connector main assembly, LCM. Connect light guide bundle LGB to the guide tube inserted in advance. Make sure that flexible section for LG FSB is straight. Pull the guide tube slowly and pass LGB through. Let's assemble LCM. Clean the mating surface with LG probe assembly, LPA, first. Apply dedicated grease on the O-ring attached to LPA. Apply the same grease on the O-ring attached to air guide. Insert LGB into guide. Take care not to tangle LGB around air guide. Make sure the tip of LGB touches glass. Apply Loctite on 3 screws and screw in. Fix LGB by fastening screws with a torque driver. Put sealing compound in the screw hole. Apply the grease on O-ring and screw in sleeve. Attach connector ring and fasten 2 screws. Assembly of undulation wire. Prepare a jig for soldering sleeve. Apply flux on the area to be soldered. Fix sleeve and solder it. Put up and down, right and left sleeves in each groove correctly and attach holder. Connect undulation wire to drum wire assembly DWA by rotating sleeve. Rotate angle knobs and check for any play. In case of much play, reduce it by adjusting sleeves. Attach plate upside and plate downside. Fix both plates with screws. Assemble stoppers. Fasten stoppers with screws. Adjust bending angle by sliding stoppers. Attach cover. Soldering of CHA cable. Pass CHA cable into operating section. Install relay board and solder wires. Final procedure is to solder grounding wires. After all, check and see if the normal image is obtained. Connection of tubes. Fit the length of WJT in fitting part. Insert ring and taper ring onto WJT. Take care not to attach taper ring reversely. Expand the inlet of WJT. Insert WJT into fitting part. Fit the length of FCT in fitting part. Excessive length of FCT should be cut. Insert ring and taper ring onto FCT. Insert a guide spring into FCT and attach FCT to fitting part. This allows smooth and easy insertion of FCT. Fasten ring tightly. Attach upper and bottom joint cover. Assembly of operating section part 1. Apply grease on O-ring and attach side cover with 2 screws. Attach cap. Attach holding cover to the operating section. Prior to attachment, apply grease on O-ring. Make sure holding cover does not catch any contents. Attach ring. Fasten ring tightly with the jig. Adjustment of ISA position. Hold the operating section so as air-water button come to upper position. Loosen screw and ring. Make fine adjustment of ISA position by rotating ISA gently. Scale marked on ISA should be located the overhead. Fasten ring. Fix set screw. Then, put the rubber ring back. Assembly of operating section, part 2. Put holder on operating section. Apply sealing compound on the threaded portion of 2 lower lock inlets and attach them to operating section together with holder. Do not apply excessive torque when fastening these inlets. Fasten screws. Bond nameplate to holding cover with rubber glue. Attach forceps opening valve. Let's take a short break. Now back to disassembly and reassembly of angle knob. Disassembly. First, remove ring and take out LR knob. Remove UD knob in the same way. Remove special screw for LR knob. Rotate cover ring clockwise with a jig and remove lock knob. Loosen 2 screws attached to ring and remove it. Remove friction plate assembly. Loosen 2 screws attached to ring and remove it. Remove shaft assembly. Loosen 2 set screws and remove fixing ring. Then take out friction ring. Remove cover ring. Remove lever assembly by removing 3 screws. Remove 3 screws. Then remove shaft. Loosen 2 set screws and remove ring. Remove special screw. Remove friction ring by rotating counterclockwise. Loosen 2 set screws and remove ring. Reassembly of angle knob. Screw in ring with compass or jig firmly and fasten 2 set screws. Please be sure that O-rings used in this section should be cleaned and grease should be applied on them before installation. Attach friction plate in the same way. Install friction plates in order as seen on the monitor and fix with a ring. Rotate friction plate counterclockwise until it stops, and turn back slightly. Fix special screw in this position. Check the friction if the undulation is locked in lock position properly. If not, adjust the special screw position and check it again. Straighten bending section and make sure that the cutaway position of shaft is in proper directions. Attach shaft assembly for up and down. And fix with 3 screws. Attach cover ring with compass. Attach lever assembly and fix with 3 screws. Attach friction ring. Screw in ring and fasten 2 set screws. Attach shaft assembly for left and right. Fix ring and fasten 2 set screws. Attach friction plate assembly. Fasten ring. Adjust LR friction in the same procedure as UD friction. Then attach lock knob for left and right. Fix 3 screws on LR friction plate. Attach UD knob. Fasten ring. Attach LR knob. Fasten ring. Check all functions of angle knobs and lock lever before finish. Replacement of setup board assembly. Remove cover with a jig. Take care not to scratch the cover. Remove 2 screws. Push out the setup board assembly. Pull out gently setup board assembly without applying any excessive force on the cable. Cut tie lap. Unsolder lead wires. Reassembly of setup board assembly. Solder lead wires. Be careful not to touch plastic receptacle with soldering iron. Fix lead wires with a tie lap. Apply dedicated grease on O-ring Then insert setup board assembly into case. Make sure cable is not squeezed by setup board assembly. Fasten 2 screws. This is the final procedure.
Adjustment of CCD drive. Open the panel cover and set knobs of potentiometers around the center position. Set potentiometers for block level and gain level at approximate central position. OG should be turned fully counterclockwise. Phi, Phi H and Phi S should be set at 1 o'clock position. First of all, turn Phi S fully clockwise and return counterclockwise gradually. Stop turning when yellow smear disappears in the bottom. Turn Phi H fully clockwise and return counterclockwise gradually. Stop turning when the clearest image is obtained. In case of full turning on Phi, yellow smear appears on the top and bottom. Turn gradually counterclockwise until smear disappears. By turning OG clockwise, image jitters horizontally and may disappear for an instant. Turn counterclockwise gradually and stop when the highest resolution and brightest image are obtained. Adjustment of black level. Let us explain how to adjust black balance in brief way. Select manual light control and set illumination level at minimum condition. Press sensitivity button to set 4 times. Connect composite output of EPX302 to the channel 2 of the oscilloscope. Select 50 mV range and horizontal synchronization. Adjust GB to get 50 mV of green output. Same as RB and BB for 50 mV output. Gain adjustment. Set the sensitivity button at normal and RG at 1 o'clock position. Select 200 mV vertical level with the oscilloscope. Adjust the knobs of GG and BG potentiometers respectively to have 500 to 600 mV output. Make fine adjustment for minimum output difference between GG and BG. Scope adjustment is completed. Let's go into checking of the scope relay board. whether trouble is caused by a scope or EPX302 can be investigated. Select vertical synchronization with the oscilloscope for this procedure. Check DC 20 volts. VDD terminal should be 18 volts. Bias should be 10 volts. OG 7 volts. And plus 9 volts. Next procedure is checking waveforms of phi H1 and phi H2. Set the oscilloscope time axis at 20 microsecond range. Phi H1 waveform should appear above the basic axis. Phi H2 has reverse phase. In case phi H1 and phi H2 are connected wrongly, no image is available. Let's observe vertical transfer waveform of the imaging area. Select 5 volts and 5 millisecond range with the oscilloscope. Nine volts is a basic axis for only phi 1. Phi 2. Phi 3. Phi 4. Let's observe vertical transfer wave with the same setup of the oscilloscope. Phi S2, Phi S1, Phi S3, Phi S4. Phi S4 only looks active low. Let's check DC voltage of the CCD. ID 10 volts. IG 5 volts. OG 7 volts. OFD 15 volts. With the same setup of the oscilloscope, let's check vertical transfer pulse of the imaging area. Terminal to be checked is located in the left side of the board. Phi 2, Phi 1, only Phi 1 is active low. Phi 3, Phi 4. This is vertical transfer pulse of the storage area. Phi S4, Phi S4 only is active low. Phi S3, Phi S2, Phi S1. Next procedure is to observe horizontal transfer pulse to be transmitted to the CCD. Set the oscilloscope time axis at 20 microsecond range. Phi H1, Phi H2. Take notice the level becomes lower than Phi H1 and Phi H2 measured at the input port. This finished checkup of the relay board of a scope.
as each scope has its own adjustment methods, assembling methods, and glues, sealing compound, grease, and fastening torque.